Good afternoon, folks. We're going to give it just another minute or two to see if we have any late joiners with us this afternoon. Beautiful fall day here in central Pennsylvania after all the wet weather we had last week. Give it another few seconds. Okay, folks, I have 102. We're going to go ahead and get started. I want to welcome all our listeners back to another webinar with Chris Daly from the Drive to Survive. Many of you may have joined us back in March when Chris shared his expertise with us regarding the causes of rollovers and how we can prevent them. During today's webinar, Chris will be sharing his expertise on understanding fire apparatus braking efficiency and the importance of brake adjustments. Obviously, trying to get a full-size piece of fire apparatus stopped quickly, especially during an emergency situation, such as a car pulling out in front of you while you're traveling 55 miles an hour, is quite different than getting your personal vehicle stopped. In a few moments, I'll let Chris tell you about himself and his career as both a volunteer firefighter and his career in law enforcement. I'm sure we'll have plenty of questions throughout the program. We're asking you to use the question answer feature to send your questions, and we'll attempt to have Chris answer all of them. Please note, if we can't get them all answered in our allotted time, we'll get answers to you via email in the days following the webinar. Before we begin with Chris, I briefly introduce you to Provident. Provident's an insurance company that got started in 1902 as an independent insurance company in Pittsburgh. In 1928, they began serving volunteer fire departments with a customized blanket accident and health insurance policy. Today, we provide volunteer, combination, and career firefighters and emergency medical responders with a multitude of programs. We also offer special risk and transportation insurance programs. Provident was named the top insurance workplace by the Insurance Business of America magazine for the last 3 years. And we're currently waiting on word about 2021. Briefly, some of the programs that we offer: we have an accident and health policy available to first responders. And if you're an accident and health client, you would have access to our first responder assistance program for you and your immediate family. We also offer a 24-hour accidental death and dismemberment policy, group term life insurance, critical illness and cancer policies, and of course, our Fire Plus property and casualty insurance program. And if you're a property and casualty client of ours, you and your members would have free access to our online Fire Plus Training Academy. Today, I'm happy to be able to once again introduce Chris Daly, the author of the Drive to Survive, The Art of Wheeling the Vehicle. And today we're going to be talking about vehicle braking. Chris?
Thanks, Ed.
Stop sharing my screen and turn it over to you.
All right. You can hear me all right then?
I can hear you fine.
Okay. So welcome, everybody. I appreciate you joining us today. As Ed said, what we're going to talk about is understanding fire apparatus braking efficiency, which essentially is a fancy way of saying, why does it take a fire truck so long to come to a stop? Which obviously is a very important topic for any fire apparatus operator to understand, or driver trainer. Quick background about myself. My name is Chris Daly. I hail from Chester County, Pennsylvania. I've been involved in the fire service for about 31 years. I was active for 23 years until I got too busy teaching this program, as well as having 2 daughters. And as everybody out there knows, life happens. But in addition to my fire service career, I've spent 24 years as a full-time police officer in Chester County, PA. And I specialize in crash reconstruction. So we're the guys who come out in the middle of the night, tie up your rescue truck for 4 hours while everybody stands around complaining about what's taking us so long. And we're the guys trying to put that crash back together to figure out who was at fault, who was going how fast, and all that sort of good stuff. So as a result of my background in both the fire and police side of things, I started to notice a lot of crashes involving emergency vehicles, especially fire apparatus, ambulance, police cars. To make a very long story short, I put together a program to help address what I felt was a pretty big gap in driver training regarding vehicle dynamics, taking the crash reconstruction concepts, boiling them down so that they were easy to understand, and then going out and teaching them to the fire service and emergency services. To date, the class has been presented about 535 times across the United States, and have had about 25 to 26,000 emergency responders attend the class. So today what I did after talking to Ed and Sam was took one topic that I've noticed some issues with and made it into a shorter seminar. Normally the first seminar runs about 2.5 hours. I have 5 or 6 different seminars as well as an instructor development program. But today we're going to concentrate strictly on stopping distance and make it nice and easy, hopefully, for everybody to understand. So that said, let's jump into the program, talk about stopping a fire truck. And in order to do that, the first thing we need to understand is the concept of energy. And as I always say, the fancy term is kinetic energy, but don't let that freak you out. Kinetic energy is no different than a bucket full of water. In our case, the fire truck is the bucket, and the energy we have driving down the road is the water in the bucket. If we want our fire truck to slow down, we need to get rid of some of our energy or dump some of the water out of our bucket, as you can see here. If we want our fire truck to stop, we have to get rid of all of that kinetic energy or dump all of the water out of that bucket. The problem is we can't just make kinetic energy disappear. We actually have to turn our kinetic energy into a different type of energy. And the way we do that 99.9% of the time is by applying the brakes. And when you apply the brakes, that brake pad will rub against the disc or the drum, depending on the type of vehicle you're driving, and create friction. And that friction, for lack of a better term, burns off your kinetic energy, slowing and stopping the vehicle. That's the ideal scenario here. You can see this fire truck's heading down the road. Hopefully you see my cursor. It's full of energy. That waterlark, I apologize for the rough graphics. Hopefully one day I'll be able to get nice graphics, but nonetheless, hopefully it makes the point. As you apply the brakes and you start burning that kinetic energy off, you can see that water starts to go away, and eventually the water goes completely away and your truck stops. That's the ideal scenario. Now, what happens if you're driving down the road, somebody pulls out in front of you and you slam on their brakes and your wheels lock up for a second? So forget about anti-lock brakes. Your wheels lock, so that brake pad is no longer rubbing against the disc or the drum. In that case, the friction has to come from the tire skidding across the road surface. There's a lot of argument in the crash world as to what a skid mark is, but one of the more commonly held beliefs is that asphalt's made up of sand, gravel, tar, all sorts of petroleum products. And when that tire starts to skid across the road surface, it creates so much heat it actually liquefies the oil in the asphalt, causing it to float to the surface. What's left behind is that residual oil. That's your skid mark. Whether you believe that or not, I will tell you this. Once you enter a skid, you lose all steering control of the vehicle until you use up all of your energy and skid to a stop. So again, in this case, the fire truck's driving down the road full of kinetic energy. The driver slams on the brake. Those wheels lock up. The tires start skidding. And essentially, like erasers, they erase that kinetic energy, getting rid of this water, and eventually bringing the vehicle to a stop. Now, what happens in our third scenario? You're driving down the road. Midway through your skid, before you get rid of all that energy, someone pulls in front of you and you hit them, or you go off the road and hit a tree. So now, how is this remaining energy dissipated? By crushing the metal of the vehicle. That's how a crash guy can go to the junkyard the next day, measure how badly crushed a car or vehicle is, and figure out how much energy it would have taken to crush that much, to crush the vehicle that much. It's called speed from crush. Those are the 3 ways we bleed off or burn off our energy. All right. Now, keep in mind, heavier vehicles and faster vehicles have more water in them. All right. And when I say water, I mean kinetic energy. I know we're talking about fire trucks. It can get confusing. And that is why it takes heavier and faster vehicles longer to come to a stop. We'll get into that a little bit in a minute. So the ways to bleed off our energy, as I said, apply the brakes, skid the tires, crush the vehicle. I recommend sticking with the brakes for obvious reasons. And when that doesn't happen, bad things occur, as we're going to see here in this video, which was taken somewhere in the Southwest. I forget where exactly, but what you'll see is a dump truck who loses its brakes, probably because of brake fade. I'm just speculating. And you'll see the amount of energy released during the crash. Obviously a serious crash. And I'm willing to bet that unloaded dump truck doesn't weigh much more than any of our fire apparatus. So that shows you how much energy you're responsible for controlling when you're driving an emergency vehicle to a call. And if you lose control of that energy, this is what happens. So this is a formula to figure out how long it's going to take a vehicle to skid to a stop. I would ask nobody freak out. There's no test. I'm not going to make you memorize this. I'm just trying to make a point. But the stopping distance of a vehicle that we use in the crash reconstruction world is equal to the speed of the vehicle squared divided by 30 times F, which is the coefficient of friction or drag factor of the highway in combination with the braking effectiveness of your vehicle. Now, this is the way we get that F, all right? And again, don't freak out. There's a whole lot of math here. But that F, that drag factor, the ability of the vehicle to grab the road and stop itself depends on three major things. Number one, how slick the road is. Obviously, a dry road is more grabby. It has more stickiness than a wet road. The slope of the road, it's going to take you longer if you're skidding downhill than uphill. And the braking efficiency of the vehicle, meaning the vehicle's ability to stop itself. And that's what we're concentrating on today, that braking efficiency of the fire truck. Because if you're driving down a road in a car and a fire truck on the same road, coefficient of friction, that stickiness of the road, and the slope, whether you're going up or downhill, is the same for both vehicles. The difference is how well the vehicle is able to stop itself. And that is what we need to understand in the fire world. Now, ideally, when I go to a crash scene, I'm going to take the actual vehicle and go out and skid test it. And I have a device I mount up to the dashboard of the police car. I'll show you a picture of that in a minute. And we skid test the vehicle. And that'll tell us how sticky the road is and how well that vehicle is able to bring itself to a stop. The problem is when myself and my fellow crash reconstructionists get called out, the reason we're getting called out is usually because the vehicle is completely crashed and we're not able to do this. We're not able to go out and actually skid test the crashed vehicle. So we have to use some ballparks. We have a lot of ballparks we use for commercial motor vehicles. I'm going to show those to you. And then what I'm going to show you is we went out and actually validated it by skid testing fire trucks. And we'll get to that again in a few slides. But typically, when I look at braking efficiency of a commercial motor vehicle, which is a fire truck with we're just a commercial motor vehicle with a fancy paint job, we are finding that most commercial vehicles have a braking efficiency around 65%. So what does that mean? If you're driving down the road in your Honda Accord, or I'm in my police car, and we slam on the brakes in that car equipped with hydraulic brakes and car tires, I can usually use about 100% of the road's ability and the vehicle's ability to come to a stop. If you're driving in a commercial motor vehicle like a fire truck, you can only use as little as 65% of that braking ability to come to a stop. And as a result, your fire truck is going to skid much further. Two major reasons for this. Number one, air brakes. Air brakes, all right, when you drive your regular car, you have hydraulic brakes in your Honda Accord. When you hit the brake pedal, those brakes engage almost instantaneously. There's a little bit of a lag time, but we're talking about microseconds. In a vehicle with air brakes, when you hit the brake pedal, you're opening a valve. It sends air out through these long hoses and in these complex chambers, and it takes time for those brakes to fully engage. Depending on the age and the condition of the vehicle, it could take a half second to 1 second waiting for that air brake system to fully charge up and give you your full stopping ability. So you may have just added 60, 70, 100 feet to your stopping distance waiting for the air brake system to fully kick in. The other issue is your truck tires. Your personal vehicle has nice soft rubber tires, gives you good traction, good handling, but they wear out relatively quick. Truck tires are designed to carry heavy loads over long distances without wearing out. And as a result, that truck tire is made of stiffer rubber. And that stiffer rubber, while it doesn't wear out as quick under heavy load, doesn't grab the road as well. It's more slick. So your truck tires are working against you as well. So your air brake system and your truck tires are going to contribute to a longer stopping distance. This is why if any of you guys cover any major highways, I cover back in my active days, Route 202 in Pennsylvania, Eastern Pennsylvania, you may get to a crash scene involving a heavy truck and see these huge, long, dark skid marks and say, wow, this guy must have been going 100 miles an hour. That's really not the case. It's because he was a commercial motor vehicle. He had those air brakes and truck tires. And as a result, it took his vehicle a lot longer to come to a stop. And that's evidenced by those skid marks on the highway. So it's very important for our fire apparatus operators, our driver trainers, to understand this concept of braking effectiveness, braking efficiency. So what we did was I wanted to prove everything I've ever taught. I always say 65% in Drive to Survive program. Had said it about 535 times, like I said. I wanted to go out and prove that was right. So what happened was our serious crash assistance team, SCAT, from our county reached out to several crash reconstruction teams in the Philadelphia region. Several counties brought their crash teams out. Pennsylvania State Police came out and helped out. Then we brought in 10 fire trucks that were willing to let us go out and skid test them. When we did that, we actually let the firefighter drive the truck to get some experience in panic stopping the fire apparatus. And we instrumented all of the trucks with these, what are called accelerometers. This is what I mount to the dashboard of the police car when I go out at a crash scene and try and determine the drag factor or stopping ability of that road and vehicle. So what we wanted to do was validate what is the braking effectiveness of a fire truck. So we shut down a road because we're cops. We can do that kind of cool stuff. And we went out and we brought the fire trucks down and skid tested them. Before we did that, what we did was we weighed each truck. So not only did we have our crash teams there, we brought out our truck inspectors. As many of you know, the police departments usually have a truck inspector or two on the ranks. We weighed each truck to make sure they weren't overweight, to try and get some data there. That's a whole other discussion. And then we had the truck inspectors go underneath and measure the push rod strokes for the vehicles equipped with drum brakes. And that's very important. That's when we get into these brake measurements, which we'll talk about toward the end of this class. But once we made sure the vehicles were properly inspected, we went out and skid tested. Now, here's a very important point. Of the 10 trucks that showed up, 2 of them, 20%, were put out of service by our truck inspectors because the brakes were not properly adjusted. And in one case, the whole front air line was blowing air out because it had a giant hole in it and it had just come back from getting serviced. So this is not a joke. Can you imagine if one of those vehicles had been involved in a crash because it wasn't able to stop properly? And when we did a post-crash inspection, we determined the brakes are out of adjustment. So for you chiefs who may be listening, for your driver training coordinators, that is a huge thing. And that's why we're here to talk about it today. We'll get more into that in a little bit. So as I said, 2 apparatus were placed out of service due to brake adjustment issues. We then went out and we skid test. Here's a drone shot. We skid tested engines, tankers, a 2-week-old Baker aeroscope. I was very nervous when we did that one, but it all worked out okay in the end. And what we found was everything was almost similar. It was really impressive to see how the math worked out. I was expecting all sorts of drama, screeching tires, things you see on TV. And quite frankly, it was pretty boring, as we're going to see here. This is a drone shot of an engine from West Whiteland, who was very kind to bring all of their apparatus out to help us. And as you're going to see, it didn't even leave skid marks. And if this was a crash reconstruction class, I would explain why, but I won't bore you with that reason. Pretty much the vehicle wasn't able to generate enough braking force to lock those tires. And like I said, that's a much deeper discussion. But here's the results. Whole bunch of numbers. Don't freak out. We skid test each truck 3 times. And then I compared it. So after we skid test each fire apparatus, you can see engines, you can see a rescue, you can see a tanker, you can see a tower ladder. Some of these had anti-lock brakes. Some of them did not. Some of them had drum brakes. Some had disc brakes. Some had a combination. What was interesting was we skid test each truck 3 times and averaged it. Then we went out and skid tested a police car. And what that did is it told us what an actual vehicle could generate as far as braking effectiveness. And then we came up with a percentage. So as you can see, 71%, 51%, that was a truck that had bad brakes. So let's disregard that one right now. But 71%, 71%, 68%, 70%, 69%, 64%. I've been teaching 65% for the longest time. This is darn near right in there. And as you can see, regardless of the type of vehicle, whether it was a tank or engine rescue, what type of brakes, we only really ranged from 71 to 64%. And the 64% was the brand new tower ladder. And I'm convinced that the driver probably wasn't cranking on the brakes as much as he could because he was a little bit nervous. And I understand that. So let's take that one out of there and you go 69, 70, 68, 71, 71. And then again, I love it when a plan comes together. So this validated the fact that fire trucks have a much, I guess, less ability to brake than a regular car. So what does this mean to us as drivers? All right. The crash guys are very excited about the numbers. I realize by now you're probably tuning me out. The bottom line is this. Most fire apparatus can only generate about 68% braking effectiveness. So that's going to mean that our fire truck will skid much further. Why? Because of the truck tires and the air brakes, like we talked about. People ask me about weight. How much does weight have an issue compared to a car? It's a much longer discussion involving a lot of math. So what I'm going to tell you is the bottom line is, believe it or not, the weight really doesn't matter as much. The easiest way to explain that is a car has 4 tires that are erasing the energy. A fire truck has 6. A heavy fire truck may have 10. So there's more erasers. And in the end, it balances out. Again, I'm oversimplifying this. I would never say that in court, but I'm just trying to make it more understandable for the, fire apparatus operators, the driver trainers who don't have the crash background. And if you want to reach out to me, I can explain it further. So average braking efficiency we talked about, that 68% assumes the brakes are properly adjusted. Okay. What we found, as I said, was 2 of the fire trucks showed up with bad brakes, for lack of a better term. There's no easy way to say it. Those fire apparatus, one of them was so bad we didn't even skid test it. We put it immediately out of service. They took it right to the shop. The second one, we were actually able to skid test before we fixed the brakes, adjusted them properly, and after. And what we found was when it was skid test with out of adjustment brakes, that braking efficiency dropped to 51%, half that of a regular car. Can you imagine, again, the liability if you're involved in a crash and the crash investigators figure out that your brakes are out of adjustment? So the fire apparatus had a 45% increase in stopping distance when compared to a Ford Crown Victoria. That's a regular apparatus. The apparatus with out of adjustment brakes had a 95% increase in stopping distance, almost twice the distance of a car. All right. And again, that's one of the big things when I do the full program. I really hit on the fact that these younger drivers especially need to understand when you park that fire truck, or I'm sorry, when you park your car, you park your Honda Accord in the parking lot, whether you're a volunteer coming in for a call or you're a career guy coming in for your shift, when you park that car and you walk in and get behind the wheel of your fire truck, the dynamics of that vehicle have changed tremendously. You cannot drive the same down the road in a fire apparatus as you normally would in your Honda Accord. And this is one of the major reasons why. And if you're in the rollover class, you heard me talk about that as well. So if you guys are like me, firefighters tend to be more visual, cops are more visual. Let's look at it on a chart, right? So a regular car, in this case, a fire truck, at 30 miles an hour on a dry asphalt road, which is what we were skid testing on, takes around 37 feet to stop. Now, don't go using these exact numbers. It all kind of depends a little bit. This is what we got that day under those weather conditions with that humidity, etc. This is a general concept I'm trying to explain. But it took the car 37 feet to come to a stop. Took the fire truck with properly adjusted brakes 54 feet to stop. Took the engine with out of adjustment brakes 66 feet to stop at 30 miles an hour. 40 miles an hour, as you see, as the speed increases, this disparity grows. Police car, 66 feet to come to a stop at 40 miles an hour. Fire truck, 96 feet to come to a stop at 40 miles an hour. 2 out of adjustment brakes, 118 feet to come to a stop at 40 miles an hour. Now, this distance between the police car and the fire truck with regular brakes, the difference is about 30 feet. Is that the difference between skidding into an intersection that you didn't, you forgot was coming up ahead of you, or the light suddenly turned in a negative way? Absolutely. That 30 feet, while it doesn't seem like a big deal, actually could be the difference between a crash and not a crash. I'm going to show you a great case study of that at the end. The other thing to keep in mind is this is skid distance. All right. In the full class, we talk about perception reaction distance, which we're not going to get into today, but we would actually have to add perception reaction to this distance, and it becomes much, much greater. Right. But again, that's not today's discussion. What I want you to see is this disparity between your regular car and a fire truck when it comes to coming to a stop, and especially a truck without a service or out of adjustment brakes. At 50 miles an hour, we see it goes to 104 feet for the police car, 151 feet for the engine, and 184 feet for that fire truck that has out of adjustment brakes. And at 60 miles an hour, you're looking at 148 feet, 217 feet, and 265 feet to come to a stop. So this, again, is a visual representation of how much longer it's going to take your fire truck to come to a stop if you're driving it, especially at higher speeds. All right. And one of the ones I talk about in the full class, let's say you're traveling behind this car. You're behind the car. You're both going 60 miles an hour. Both of you have to slam on the brakes for whatever reason. There's debris in the road. Perhaps somebody pulled out of a driveway. When that car stops at 148 feet and you still have almost 60, 70 feet of stopping distance, are you not going to slam into the back of that car and cause a very serious, if not fatal, crash with this 30,000-pound engine? Absolutely. And that is why following distance is very important to understand as well. So the results of the fire apparatus skid test that we went out and did in Chester County were very consistent with previously conducted studies regarding the efficiency of a commercial motor vehicle. All right. So like I said, it was dead on right where we wanted it, and that made me very happy. What I have here is another video. This actually comes from E1. I'm not endorsing E1. They have this on their website. I thought it was a great example to discuss. It's a crash truck. They go out and actually skid the crash truck. And what we're going to do is we're going to take their numbers and we're going to do the math that I showed you. We're going to see if this truck lines up with what we're talking about. So they stopped that truck from 56 miles an hour and 213 feet. Now, the variable I don't know is how sticky that runway is. They were out there. I'm guessing it's around 0.7. When I go out and skid test an asphalt road, if I find 0.7 and 0.75, that's about right for the stickiness of that road, which gives us a braking efficiency of this apparatus at 70%, which is right in there around the 0.68 we talked about, that 68% that we got when we went out and did the skid test in Westchester. The drag factor, if that road was a little bit stickier, all right, if it was a stickier road, it would be around 61% braking effectiveness and 54%. And I'm just ranging this. But let's say here that depending on how sticky that road is, the braking efficiency of that E1 crash truck that they provided on YouTube is between 61 and 70%, which is right in there with what we're talking about. So this just validates everything we've discussed. I like to do that. I like to prove that the math works. I love it when a plan comes together. So how does this affect us as drivers? All right. A lot of times, especially in smaller departments, you need drivers. You go out, you driver train, and you really don't learn the ins and outs of the vehicle. Okay. And when I was younger, I went through something similar. So we need to start teaching our drivers about the brakes, especially. There's a lot of things we need to improve upon, but the brakes is something. So this is a brake chamber. All right. And it's not normally this easy to be seen. This is actually one of those bobtail chassis you see out at FDIC, where it's the cab of the truck and then two frame rails where you can see everything nice and neat. So I walked by it. I said, oh, this is a great way to get a picture of the brake chamber to show. This is the brake chamber. This here, if you're seeing my cursor, hopefully you can, is the push rod. Okay. And that's what we're going to concentrate on here. And the reason is when you engage the brakes, this brake chamber fills with air, pushes the push rod out, cranks on this device here, which engages your drum brakes. Now, this is a drum brake. Disc brakes are different. That's a whole other conversation. But most of us have drum brakes on our fleets right now. If you're fortunate to have the finances to replace your apparatus regularly, you may have a new apparatus with four-wheel disc brakes. I teach all over the country. I'm going to places where they have 40-year-old fire apparatus. So this is not uncommon for them to see. Very important, all right? So this engages the brakes, this push rod. So what I'm going to show you here, this is a video we took, and you normally can't see these pieces this easily, but this was a truck involved in a very serious crash and the whole front end got ripped off. So I was able to get some easy videos here. What you're going to see when the driver engages the brakes is this push rod up here around this circular disc is going to come out, and watch how it engages the rest of the brake. One more time.
Hey, Garrett, you play the brakes just on and off. Yeah, just pump them.
So as you saw, the push rod came out. It twisted this assembly. I'm not going to get into the names of this stuff just yet. That's a whole other class. And then it engaged the brake pad down here against the drum. I'll play it one more time so you can watch that. One more time.
Hey, Garrett, you play the brakes just on and off. Yeah, just pump them.
So when we do truck inspections, either on the side of the road to look for violations or safety violations or post-crash, we're looking at this push rod stroke. How far did this push rod come out? And the reason we do that, well, because, and I'm going to skip ahead here, when you engage the brakes, this push rod pushes on this device here, which engages the brakes. Ideally, this should be at about a 90-degree angle. If the push rod comes out too far, you lose your braking efficiency. The brakes aren't working as well as they could. So we measure this push rod stroke, it's called. And some of you may be familiar with this. When I teach out west, when I started teaching in California a few years back, A lot of those engineers actually go under the truck every day and measure the push rod stroke. I was very impressed to hear that they did that. They're trained to do that. They do it as part of their daily checks, which is incredible. Unfortunately, the rest of the country where I teach, I don't ever hear of departments doing that. So it's important that you have either a diesel mechanic, or if you actually get the training in-house, which I recommend, have someone measuring those push rod strokes on a regular basis. It could be as simple as calling the police department and having one of their truck officers come out and measure it for you on a regular basis. But make sure that these brakes are not out of adjustment. If this push rod travels too far, you're out of adjustment, and that can lead to decreased braking effectiveness, increased stopping distance, and a huge liability. All right, so let's go back. This is that same truck. And what I'm showing you here is how our truck officer measured the push rod stroke. What he did was he put a mark with soapstone right here at the face of the plate here. And he's going to measure how far that travels. It's only allowed to travel so far. And that distance depends on the size of this brake chamber. And there's charts for that. I provided in the book. Your truck inspectors will probably have access to charts they can give you. So you would have to determine what size brake chamber your apparatus has and what the maximum push rod stroke is allowed before it's considered a failure. So let's watch how he does it.
Ready? Yes. Ready. Inch and a quarter.
What is it?
Inch and a quarter.
Okay. You're not going to get any push rod stroke on the way on the left front, right?
So it was an inch and a quarter push rod stroke. That's how he did that. And that was in compliance, I believe, for that particular brake. I'd have to look at the report. So that is how we measure push rod stroke. When we say brake adjustments, that is what we're talking about. Okay. So it's very important for you to understand how you need to have these checked on a regular basis, because if your brakes are out of adjustment, the fire truck will not stop as effectively as it could. And you could find yourself involved in a crash and also facing a serious liability. Okay. So let's look at a case study. There was a crash back in 2004 in Kansas City. An engine was traveling 51 miles an hour when a civilian turned left in front of the engine. The driver applied the brakes, and after he did that, he struck the left front corner of the car, continued to skid 129 feet before hitting another vehicle head on. He then slid across grass another 95 feet where he hit a tree, killing one of the firefighters on board. When the police officers did the crash reconstruction, they went out and measured the push rod strokes, the brake adjustments of that engine. They were out of adjustment. And when they did the math, they were able to determine that if the brakes had been properly adjusted, the engine would have stopped 70 feet before hitting the tree, which most likely, probably in this case, would have prevented the fatality. So here's an example where out of adjustment brakes caused a serious fire apparatus crash. So that's pretty much it in a nutshell. As I said to Ed, a lot of this stuff is available through the full course, which you can go either online to courses.drivesurvive.org and check out. There is a code for Provident members that we will give you. Sam can send it out to you. That'll get you a discount on the online program. I'm also doing in-person programs again, thankfully. I know firefighters aren't keen on online training. I understand that. I'll be in Western Pennsylvania tomorrow. And this is also covered in the Drive to Survive textbook. I also have a YouTube channel that I started during COVID where I'm putting shorter videos online just to try and reinforce some of the more important methods or concepts, I should say. You're welcome to go watch those, share them with your drivers. And I also have a Facebook page where I'm posting things on a regular basis, usually articles related to fire apparatus crashes and that kind of stuff. So that said, Ed, I'm going to jump out and we can take some questions if anybody has any and kind of go from there, if that's all right with you.
Okay, Chris. Once again, thanks for an excellent program. So let's see what we have in the Q&A. The first question, are the brake pads made of different materials affect on braking?
So does the brake pad material affect braking? Is that?
Yeah, the question is, are the brake pads made of different materials? Question. And I'm assuming, does it affect, what effect does that have on braking?
Yes. So it's my understanding, and I always recommend you to a mechanic, but the brake pads have different aggressiveness. You can buy different types of brake pads. That is something we take into account when we do our braking calculations after a crash, how aggressive the brake pad was. So that's something I would recommend you talk to your dealer or your fleet mechanic about, as far as what type of brake pads you're using. But that brake pad and the materials and the aggressiveness can affect, how well it's able to stop the vehicle.
Okay, I want to look here in chat to make sure we have a lot of good comments on the presentation. Nothing in the chat as far as questions. So I have a question for you, Chris. As a fire chief, I got to tell you, I got the hair stood up on the back of my neck when you talk about the proper adjustments. So my vehicles get taken to an inspection mechanic once a year for a state inspection. From what I'm hearing from you, that may not be enough for me to know for sure whether or not my brakes are properly adjusted.
Correct. So like I said, the one extreme is out west. I go to California every year for a week or two and travel around and teach all over, which is tremendous to see how they do things out in the West Coast. And their engineers are checking the push rod strokes in certain departments on a daily basis. They take the truck over and they're underneath first thing in their shift. And that's not their only thing they're checking, but that's one of the things they're checking. I was very impressed with that. Many departments, like you just said, and Ed, Pennsylvania is unique in that we have an annual inspection. Some states don't have any inspection. Some are exempt from inspection. And if you go through a lot of the NIOSH fatality case studies, those become issues when it comes to equipment maintenance. So I'm recommending, I'm not going to give you a firm date and say every week, every month, every whatever. On a regular basis, you determine you should be checking that brake adjustment with someone qualified to do so. If you tell your local police officer who's a truck guy, hey, if you stop by the station once a month, we'll buy you lunch and you can go under and check all our push rod strokes, that'd be great. If you're using a diesel mechanic, or again, it's not hard to get guys trained up to do this in-house. You can go to Bendix class. There's videos online if you developed your own one. As long as you're doing it safely and checking it, I think you'd be okay. Obviously, if you get a certification from a brake manufacturer, that's going to hold up in court better. But yes, you definitely have to be keeping an eye on that and not forgetting. And document that. Certainly document that, because you want to make sure, heaven forbid you're in a crash and the issue of maintenance of your apparatus comes up. You want to be able to show that you're checking it on a regular basis. And one thing I forgot to mention, this goes, a lot of people say, well, we have automatic slack adjusters. This still pertains if you have automatic slack adjusters. Because what can happen is sometimes the brakes aren't being applied hard enough to ratchet that automatic slack adjuster, or there may be some sort of defect, through time and wear with the automatic slack adjuster. So even if you buy a new apparatus and you say, oh, we have these automatic slack adjusters, you still need to go underneath and check, because there may be a failure in that system as well.
Okay, so I went back into chat. A question did pop up in chat. How does brake fade affect stopping distance?
That's a very good question. In the full class, we go into brake fade pretty in depth. Brake fade, if you start to experience brake fade, you're going to have a much longer stopping distance. Two types of brake fade, one being drum brakes, where the drum brake starts to overheat, that drum expands. So now what happens is that push rod stroke is going further to, engage those brake pads against the drum. And eventually, as you saw, if that push rod stroke gets too long, you lose your braking effectiveness. So that drum essentially swells up from that excess heat. And then once one brake fades, the others quickly follow, because they're trying to make up for burning off that excess energy. Then they are more prone to overheat. It's called a cascade failure. Once one goes, the others come pretty quick. That's why, in Pennsylvania, you drive around, you see all sorts of runaway truck ramps all over the place for just that reason. So brake fade is a significant issue, and brake adjustments is one way to prevent that.
All right. That question came from Kevin Rooney. The next question, and it popped up in the chat, is from Bill Hadley. Well, my personal truck, it seems like I'm always glazing over. How often do you need to check for this glazing on an apparatus that may affect the braking process as well?
So glazing, it's funny when you get into disc brakes and glazing, there's actually controversy is a strong word, but there's different theories out there on what happens. One of them is you get that binding agent that holds that brake pad together, creates a glaze, which doesn't grab as well. The other theory I heard is that what happens is the binding agents actually start to heat up to the point where they off gas. and that gas gets trapped between the pad and the disc and makes it difficult for that brake to engage, that brake pad to engage the disc and create that friction. So as far as glazing over, I would have to research that before I actually answered it, but it's something you obviously want to talk to your mechanic about. Does it mean your truck is overweight? Does it mean there's something going on with the type of brake pads you're using? I'm not quite sure, but glazing is an issue, and it's more of an issue on disc brakes from what I understand.
Okay. So I have some more questions did pop up in the Q&A. Chris Malima. I've always been taught that air actually holds brake shoes off the drum. Chris stated that air pushed the rod to engage, which actually happens.
So there are two types of brakes on your apparatus. And I'm going to be honest with you, I don't have this prepared to answer, but there's a service brake and then there's a parking brake. Foundation brakes, parking brake, here all different. There's two sides to an air chamber. When you engage the parking brake, it charges the brake and it engages that brake pad against the drum to set that parking brake. When you're driving down the road, you're keeping that parking brake set aside. And I would need a diagram to explain this. Chris, to make it easier to understand, there's two parts of that brake chamber. One, you're correct. You're engaging it with air to keep it from off the drum. That's the parking brake. And if you're driving down the road and all of a sudden you start to lose air, that brake chamber can no longer keep the spring compressed and the brakes engage as a safety. And there, like I said, I would need to get into probably another 15 minutes of discussion to explain that better. I'm probably confusing you more.
Okay.
I would have to tell you to get the book. That's a cheap plug, but it's explained in the book very well.
All right. So Arthur Howe has a question. Effects of weather on braking: heat, cold, rain, snow. I know they do affect, but any more details?
So the biggest issue we've seen with weather from a crash standpoint is the stickiness between the tire and the road. As far as affecting the brakes, I've heard that sometimes you may crack a drum if you have a hot drum that comes in contact with a cold puddle or something along those lines. I've never seen that in real life. I've only heard about it anecdotally. But the weather on braking, yes, a slicker road because of rain or snow or ice will create a longer stopping distance because the tire can't grab the road as well.
Okay. And then we have a comment from Chris Kubis. In my department, we check the brake travel every Wednesday when we do a weekly truck check, which is good to hear.
Excellent.
So
I like to hear that.
you mentioned it, and I want to reemphasize it. You said a qualified individual, because look, I've been around the fire service long enough to know that we all have people in our firehouses that are experts with everything. And if I went to the firehouse tonight and asked a dozen people about checking this rod, 6 of them would tell me, yeah, I know how to do it, but I'd have 6 different answers. So a recommendation, if I don't have a local police department, or in my case, maybe the state police could help us out, a good solid commercial vehicle repair person, mechanic would be the ideal person to teach this to us?
Yes, what I would recommend if it was my department is to go to a brake manufacturer like Bendix, or perhaps you have a local technical college that may give you some sort of class or certification, and attend a class that teaches you how to measure the brake adjustment of your vehicle. Keep that certificate in your folder, so that you're now trained. If you ever get sued, you can show you were properly trained by a legitimate agency. And then I would come up with a step-by-step laminated procedure that you keep in the engine or the truck or somewhere, with your binder with all the what do you call it? Your weekly truck checks, and you follow that procedure every week and you document it. So let's say, heaven forbid, you're in a crash, you get sued, you're able to show your attorney, here is the person who measured the push rod stroke, the brake adjustments on this vehicle. Here is his or her training certificate where they learned from a legitimate agency how to do it. Here is our written procedure we follow every week. Here is the documentation that it was done correctly on such and such date, 2 hours before the crash or 4 days before the crash, if that makes sense.
Okay, great. Well, I don't see any other questions in the chat, and I don't see any other questions in the Q&A. So Chris, again, I want to thank you, from attending your Drive to Survive training programs in person. I don't know how many times at FDIC and even here in my own county, and from reading your book, I know there's a great deal more to learn. But I do believe we set the stage for our listeners to pursue additional training beyond the standard EVOC training programs. For our listeners, please know that we'll be doing more webinars in the future with Chris. If you have an idea on something we should do from Chris's book, let us know. Typically, we try to stay at an hour. If we go over an hour because we're into a good subject, that's fine by me as well. Chris, how about telling our listeners how they can take advantage of the other training programs you offer?
Sure. So I have the program online now. During COVID, all of my in-person classes got shut down. I was never a fan of online training, even though I got questions about it, but I did take 4 months and put what's equivalent of my 8-hour class online. Fire departments can go in, drivers can take it individually, or the fire departments can reach out and get group codes. As you said, there's a code for a discount code for Provident members, as well as anybody who takes this particular seminar. Sam will send that out to you. And then I do in-person classes now that things are slowly returning to normal on a fairly regular basis all over the country. If you're interested in hosting a class, feel free to reach out. And then there's also the textbook, which I put together to help give, especially driver trainers or those serious drivers, a resource to use and refer to. Because as I said, you always want to be able to refer back to something. So you prevent those arguments Ed brought up that we've all been part of, where you have 4 different experts in the firehouse arguing over certain things. So if anybody has questions, feel free to reach out to me. Chris Molina, if I'm saying your name right, please reach out. I'll explain the concept of the service brake and the parking brake and the foundation brake and all that better to you. I just wasn't ready to do that today. I don't want to give out the wrong information because that's something I always get confused about, to be honest, as far as which side is which. I know how it works. Putting it in words is kind of hard. So that said, always feel welcome to ask questions to me via email or phone calls about driver training programs, crashes you may have. Hopefully that's not the case. And Ed can also help as well.
So here's the book. I have it here on the screen. If you don't have the book, I would suggest get your department to buy the book. If you want to solve a lot of arguments in the fire station, this is a good book to have as a reference material. The other thing I'll say to you is, if you have the opportunity to sit through one of Chris's classes personally, I would strongly suggest that you do it. And Chris, you mentioned you're going to be in Western PA tomorrow night. Do you want to give us the name of the department where you'll be tomorrow night?
Sure. Let me pull it up so I get it right. I will be at the Summerhill Fire Department in Summerhill, PA tomorrow, 7 o'clock. I'm sure there's still probably room in the class. If anybody out in Western PA or Lower Maryland wants to join us, you're more than welcome.
All right, great. And again, folks, I can't stress to you enough. If you have an opportunity to get to one of Chris's classes in person or make arrangements for one of his classes, I would strongly suggest you do it. I attend them every year when I get a chance at FDIC, and I learn something new every time. And then when we do these webinars, I'm learning something new every time we do the webinar. So, please, you get a chance, get your hands on the book, get your department to buy it so you can use it as a reference material. So for all of you who register for the webinar today, we'll email you the links and the discount codes that you can use to get Chris's book and additional information on his training programs. We'll also be uploading this presentation to the Provident YouTube page if you'd like to watch it again, or bring it up at your station and do it for station training some night in your classroom. As a reminder, there'll be a short 5-question survey at the end of the program. Please take time to complete it. If you have any questions or need additional resources from today, or you have any idea for a future webinar, please email us at info@providentins.com. We'll get back to you as soon as we can. And to Chris's point, if you don't have Chris's email address, if you email me at eman@providentins.com, I'll see that Chris gets your questions. So this wraps up another Provident webinar. Also, keep an eye open for a podcast airing in October with the Firefighter Cancer Support Network. We'll share the registration link to this event in our email with all of you. Until the next time, stay safe and stay healthy.